Hey guys, it is time for our very first lesson. If you have not watched the welcome video in the first slide of this, please go back and watch that, and it's going to kind of explain the rundown and how the lessons are going to work and just how everything's going to be set up. It'll be easier for you. So in this class, we are starting out with our very first unit of sequences and series. And you can see here on the first page our standards along with our targets. And it does say Advanced Algebra 2. Oops. So if you are in regular, just know that the first couple lessons are the same. But then we'll start switching over for you. All right, so if we look at the very first page, we're starting with what's called Intro to Sequences. This lesson is only 1 page long. Yay. I'm going to make this as wonderfully fun as I can, which won't be very fun, but maybe I won't be so monotone for you. Yes, my voice is really deep right now. I've had a sore throat and I'm getting over that, but I have the side effects of sounding like a man. So here we go. What is a sequence? Well, a sequence is a set of numbers with an order or a pattern. Each number is called a term. Now here's the great thing about videos. I'm not going to just sit here in silence for several minutes to let you write. What you're going to be doing as you're going, if you realize that I'm going a little fast, well, that's because it's a video. I'm anticipating that you know how to use the pause button and the scroll back button and start over button. You can do that with the video. So if you miss anything, just rewind it. Or if you need to finish writing something down, pause it. That's awesome. Videos are great. All right, so we have what's called a finite and an infinite, not infinite. I don't know. It's not finite. It's finite and infinite sequences. Okay, if you know what infinity is, you know that means it goes on forever and ever and ever. So finite would be it doesn't go on forever. So a finite sequence is, let's change my color. A sequence with a limited number of terms. It stops somewhere. It stops. It may have 5 billion numbers, but if it stops somewhere, it's finite. So an example of that would be like, and when we're talking about sequences, we put our numbers in these curly brackets. That's just the way it is. So if we have the sequence 1, 2, 3, 4, 5. That is a sequence. It has a pattern. I'm adding 1 each time. 1 plus 1 is 2. 2 plus 1 is 3, and so on. But after 5, I don't have any more numbers. It stops at 5. So it's finite. An infinite sequence is a sequence that never ends. And the only way to show that, I literally cannot write numbers forever and ever and ever. I would be sitting here until I died. So the way you do that is by putting 3 dots at the end of the sequence. So for example, 1, 2, 3, 4, 5. But this time I'm going to put the 3 dots, which means it keeps going. Yes, my curly brackets are quite terrible, but ignore that. So if I were to keep going, I would have 6, and then 7, and then 8, and then 9, and then 10, and I would keep going forever and ever and ever. I know that's infinite because it has the 3 dots. All right, so let's go deeper. So let's zoom in on our sequence. And if you look back to that very first definition, I said each number is called a term. So 1 is the first term, 2 is the second term, 3 is the third term, 4 is the fourth term, and so on. But if I'm just talking generically, the very first number, I use A sub 1. That's an A with a 1 in the bottom. That's my first term. A is just saying a term. The little number tells me, okay, well, which term is it? Is it the first term, the second term, the third term, or, so on. Now, the next term would be A sub 2. Then I would have A3, A4, A5, and so on, right? A2 would be my second term. A3 would be my third term. Now, if I just want to be generic, I can say A sub n, where n is the term number in the sequence. So if I said find A5, that means you would look for the 5th number. If I said find A sub 5,000, you would look in the pattern and you would count the pattern until you got to the 5,000th number, whatever that number was. Okay, so let's look at an example here. I have this sequence 1, 5, 9, 13, 17. Look at those numbers and see what is happening. Am I adding? Am I subtracting? Am I multiplying? Am I dividing? If you look, I'm adding 4 every time. If I were to keep that pattern going, and I know it goes because of those 3 dots, it's infinite. If I were to keep going, I would have 21, 25, 29, and I keep on going. All right. So A1, A sub 1, that's asking for my very first term. What is the first number listed? That first number listed is 1. A sub 4 is saying, all right, what is the 4th number listed? So if I go first number, second, third, 4th. The 4th number that's listed is 13. What is A sub 10? Okay, well, I had my 4th. 5, 6, 7, 8, 9, 10. Uh-oh, I don't have any numbers. But you can figure them out. Just keep the pattern going. If I kept the pattern going, I would have 33, 37. 37 is my 10th term. A sub 10 says find the 10th term. And A sub 13, well, I need to keep going in my pattern. The 13th number is 49. That's how you find a term. So when you see an A with a little number, that's telling you to find one specific number. You're going to look in this whole list and pull out one number. All right. Last little thing here for today. What is an explicit formula? An explicit formula is a formula that helps find any term in a sequence. So it's a formula that we use. If you go back to that last example here, and I said find A sub 264, well, it will take you a long time to find the 264th term. So what you need is a formula. Later on, we're going to learn how to write those formulas, but for now, I'm already giving you the formula, and I just want you to find a specific term. In fact, I've asked you to find 4 specific terms. So let's look at number 1. Number 1 says find a sub 1. I'm going to find a sub 1. If you notice, I have replaced the n with a 1. I've replaced the n with a 1. So in my formula, I'm going to replace that n with a 1. So I'm finding the first term. And that gives me 28. Now I want you right now to pause the video and see if you can figure out the rest of number 1. So I want you to find a sub 4, a sub 19, and a sub 32. And once you get that, go ahead and press play and see if you got them right. A sub 4 is 49. A sub 19 is 154. And a sub 32 is 245. All we were doing is taking that whatever term and plugging it in for n. All right, let's look at number 2. Number 2 says a sub n is 1/3 to the n plus 1 power. I'll go ahead and tell you we're not going to be able to do all 4 of these because if you type that in your calculator, it's a crazy big number. So let's just do the first one. A sub 1, 1/3 to the 1 plus 1 power. Now I'm going to show you kind of how that looks in your calculator. So you may or may not, I don't know, have this app. And guess what? I don't have it on my iPad, so I'm going to download it. Maybe. If you don't have this app on your phone, you need it. It's called Calculate 84. All right, we're going to, oh, I do have it. We're going to open that. You need to get that if you don't have it. All right, so in our example, we were asked to find 1/3 to the 1 plus 1 power. So you need to get in the habit of using your calculator wisely. So if I hit alpha y equals, you have a fraction option that pops up. So I'm going to hit enter, and it lets me type in that fraction. And I did not put parentheses, so I'm going to arrow over, arrow out, put parentheses. And then my exponent is 1 plus 1, and hit enter. Now, it gave me my answer as a decimal. I don't really like that. So if I go to math, that number 1 is going to switch it to a fraction, 1/9. Sometimes if you use the calculator or the fraction function, it gives your answer as a fraction, but it didn't this time. But anyway, our answer is 1/9. If you do the same thing for a sub 4, you're going to get 1/243. And if you keep going, you're going to get this like extremely big number. So we're just going to stop there. All right, and the last number 3, I want you to pause the video right now. I want you to try to find the first term, the 4th term, the 19th term, and the 32nd term. and from there, play the video and check your answers. All right, if you did these on your own, you should get a sub 1 is -4. A sub 4 is -64. A sub 19 is -1,444. And A sub 32 is -4,096. That is all for today. You are done with today's assignment. If you're following day by day, this should be completed on Monday, or at least by Monday. And tomorrow you'll have an assignment that goes with it, unless you want to go ahead and get that done. Have a great day.